Welcome back, everyone, to another episode of Subro Sessions. I'm Matt Ferrie, a partner in the subrogation department here at White & Williams, and I'm happy to be back recording with forensic engineer Bert Davis, a principal for Romauldi, Davidson, and Associates, as well as BDA Engineering, as we present the second episode in our series about investigating residential electrical fires. Bert, if you could please say hello again to our fantastic listeners.
Hello, everyone.
In today's episode, we dive into a term that is heard often in investigating residential electrical fires, and that term is arc mapping. Bert, to start us off, can you please tell us in general terms what arc mapping is?
Sure. So, to reiterate from the last podcast, the origin of a fire is determined by using witness information, fire patterns, fire dynamics, and arc mapping. So, essentially, what we want to do is to define an area of origin. And what we do with arc mapping is that we do an evaluation of the electrical circuit configuration, spatial relationship of the circuit components, and identification of electrical arc sites to assist in the area of origin identification. And this arc map is essentially a product of the arc survey. It's a representation of the locations on the circuits where the arcs are formed, and that arc survey involves both the identification and recognition of the characteristics of arcs.
You mentioned that arc mapping assists in identifying the area of origin and fire spread. Can arc mapping also assist in the determination of the cause of a fire?
Yes, we arc map appliances all the time. It could be a dryer, a washer, some other appliance, and we look for arcing either in the appliance or on the cord of the appliance. For example, if we have a microwave and we find arcing on the cord, and that's the only electrical activity we find, we're likely going to roll that microwave out. If we find that arcing inside the microwave and we find that there's a failure or something in the microwave near that area of arcing, that's very helpful in identifying which piece of the microwave failed. Another arc that's characteristic of a failure would be, for example, a extension cord plugged into a heater, and we find that the connection shows characteristic, what we're calling series arcs. That helps to identify that as the area of origin, particularly if we have the fire pattern coming from there. Another characteristic area of origin with arcing is saltwater fish tanks and arcing at, for example, relocatable power taps where we have a conductive liquid between the hot and neutral or hot and ground. And again, we're identifying arcing in that area, and that helps us put together the arc map, but it also helps us identify the origin.
If arc mapping can be performed in a given case, how would you describe its importance and value to the electrical fire investigation?
So according to NFPA 921, it's one of the critical methods of identification of the origin of a fire, and it's used by both fire investigators and engineers in defining the fire origin, and sometimes, as we discuss, the cause.
When the arc mapping is performed, are the origin and cause investigator and engineer acting collaboratively?
Yes, so oftentimes the fire investigators at the scene prior to the engineer, they may perform some arc mapping and even call the engineer prior to the scene investigation with the engineer to describe what they found. Once the engineer gets there, we'll look at the characteristics of the arcs the fire investigator found. We'll then try to determine if there's an additional arcs we need to look at, identify those arcs with, for example, wire ties or some other means of identifying their location to start to form this arc map that we use as one of the means of identifying an origin.
Let's talk about a few more definitions. Can you please tell us about the arc site, parallel arcs, series arcs, and alloying?
Yes, so the arc is just the location of the actual electrical activity on the conductor or other item we're looking at. The type of arc, whether it's parallel or series, can be defined by whether or not the conductor arcs to something else. So if we arc, for example, from the hot to the neutral or the hot to the ground, that would be a parallel arc. A series arc is more common to a receptacle where we'll get arcing on the line circuit or the neutral circuit, but it's on that same circuit or same phase conductor where we're not arcing to another one of the conductors. Alloying is when we have two metals meet from a fire. For example, a common alloying is from aluminum and copper. When aluminum melts on copper, we lower the melting temperature of the copper, and we try to identify if it's alloying versus arcing. Often you can tell by the melted aluminum in the shiny circuit whether or not you have alloying or arcing. Another temperature that is lower than copper for melting is zinc. Often you'll see zinc as part of the fittings on metal conduit. That zinc will melt. I've seen lab exams being held because someone will identify arcing on metal conduit and it's merely the zinc melting or the zinc fitting, and then making someone identify that area as an arc site, but it's really just alloying of the melted zinc with the copper.
You've touched on this a little bit, but can you tell us what the actual process is of arc mapping?
Sure. So we go to the scene and we'll look for areas on wiring that have arc characteristics. Those characteristics are usually a sharp demarcation. And if you have, for example, a circuit with more than one arc on the same circuit, the arc closest to the load center will likely happen last. The type and status of electrical protection is also important with arc mapping because we found that circuits protected with arc fault circuit interrupter breakers, or sometimes GFCIs, may have arcing that we can't see. The arc fault breaker identifies the arc early on, and a lot of times the size of the arc is much smaller than with a standard breaker. Another issue is if wiring's in raceway. For example, wiring in metal raceway oftentimes won't cause that raceway to deform or form a hole in the raceway, and we'll have to pull the conductors from the raceway to identify the location of the arc.
In our last episode in this series, we talked about the importance of not confusing electrical activity on a wire with thermal activity on a wire. Or in other words, not confusing arcing with melting. And alloying may also be relevant to that point as well. How does this come into play with arc mapping?
Very frequently, we run into fires which melt copper. So if we have a localized point of contact between a wire or wires and a grounded object, you'll see a very localized indentation on the wire or demarcation of damaged and undamaged area. The other thing you'll see with arcing versus melting is when they make copper wire, they draw it through a die. Under magnification, you can see the die lines. With melt, a lot of times those die lines are obscured. Other issues are corresponding damage on the opposing conductors and localized depressions. If you see small beads and divots over limited area, which you typically see with stranded conductors, that's indicative of arcing. Or you'll see a very small, round, smooth shape on the artifact. Again, that's often with stranded conductors. In terms of thermal events, we'll often see wires that are thinning. For example, a wire under tension is heated and it'll thin. The wire will have several areas of beads. It'll be tapered, it'll be blistered, there'll be multiple globules, and you'll see gravity affect the wire so that the copper is moving in the direction of gravity or downward. So oftentimes an investigator will say there's arcing on a conductor when actually it's melting.
Can you go into a little more detail about the particular relevance that arc mapping may have in the determination of whether or not an appliance caused a fire?
I spoke about this a little bit briefly, and the arc location is very important when examining appliances. We talked a little bit about microwaves, dryers, washers. Another item that's frequently arc mapped are ranges. One of the important issues with arc mapping is, for example, with a dryer, if you get a failure in the dryer, was that conductor a conductor that is energized all the time? If not, it may be a conductor that's energized only during a certain portion of the cycle of that item. So, for example, if we get a conductor on a dryer that is arced, that is going to the heating element, and that conductor is normally off. If the heat's off and we get an arc on that, we know that the heating element was on, which is important, particularly if you're saying that the fire occurred due to some defect or something to do with the heating element. You can do that same sort of thing with ranges and other sorts of appliances. So the arc mapping of appliance is something that is normally always done to determine if the appliance was causal and what mode of operation the appliance was in.
Great. So how long does arc mapping typically take to complete? And would it generally be considered destructive in nature?
So we talked about appliances, and with appliances it could be because you're taking the appliance apart. But generally when you're arc mapping the scene, it is non-destructive. And I've gone on scenes where we have one room and 4 conductors or 3 conductors. We can arc map that quickly, an hour or two, because we're tracing out the circuits and seeing which breakers they're on. Or you may have a fire that's in multiple rooms of a building or over a large area, and those can take a day or days. And again, it depends highly on the site and on the amount of damage and how large of an area you're talking about.
My next question kind of goes hand in hand with my last question, and this one is, what would an example be of when arc mapping goes well on site?
We have a small area of the fire, and then we have a lot of conductors going through that area. I've had fires, for example, in basements near the electrical panel, and we had a lot of unprotected conductors. And when I say unprotected, they're not protected by drywall or some building construction that would not allow the fire to quickly attack the conductor, and that could mask the wiring from getting attacked soon on and mask the location of the origin. So we have a fire in a basement or some other area with lots of energized conductors, and we find many of those conductors with arcs on them. They're easy to trace back, and we have very little arcing beyond that area. That gives you an idea of when you have a very straightforward scene investigation in terms of finding those arcs and defining origin.
And now sort of the opposite question. What are some scenarios when arc mapping cannot be performed effectively?
Building collapse is a major one. We get a fire and most of the building's on the ground. In that case, you typically find several issues going on. One is the building has collapsed, fracturing the conductors, moving the location of where that arcing occurred. Those fires tend to be very hot and melt a lot of the copper conductors. With the melted conductors, it can be very difficult in differentiating what is an arc and what isn't. So now we don't know where the arcs are, and we don't know where the wiring was. We discussed the AFCI breakers. They can sometimes make it very difficult even to find the arc. And again, alloying to conductors can cause those conductors to melt. And if they do melt at the area where the arcing originally took place, then you just don't see that information anymore to use that to put that together with your final arc map.
If arc mapping goes well on site, should the arc mapping alone be viewed as determinative regarding either the origin or the cause of the fire?
No, the arc mapping, again, is used along with the witness statements, fire patterns, ventilation of the fire, fuel loads. As we mentioned, the conductor location, whether it's exposed or hidden, can affect the arc mapping. So often, arc mapping is just considered one of the tools. In some instances, it can be very useful and helpful. In other instances, it may not be, depending upon construction and what's going on with the fire scene.
Sure. Do you have any final comments regarding arc mapping?
I think to summarize, what I'd like to say is when an electrical arc occurs, it releases a high amount of energy in a short time. It's that short time is why that electrical arc doesn't result in a fire, and it doesn't result in the material near it being ignited. We need to identify the arc as being an arc versus something like melt or alloying. And identifying arcing as a cause of the fire, we need to verify that the fire pattern is consistent at the location of the electrical failure. Electrical arcs are useful when narrowing the area of origin, but are only used as part of the process in defining the origin. And there can be times when it is difficult or impossible to arc map due to scene destruction, alloying, and things of that nature.
Well, thanks a lot, Bert. It's always great when we get a chance to sit down and pick your brain. It's always very informative. And to our audience, the next episode in the series that Bert and I are doing on investigating residential electrical fires is going to be on a hot topic in the fire investigation industry, and that is lithium battery fires. But be sure to listen to the next episode of Subro Sessions, which is not the next in our series of residential electrical fires. The next episode is going to be released on the third Tuesday of next month, May 21st in this case. You can find past episodes of the podcast and relevant case updates on the Subrogation Strategist blog, all available at whiteandwilliams.com. Thank you very much.
We would like to remind everyone that the contents of this podcast should not be construed as legal advice or to give a legal opinion on any specific facts or circumstances. Prior results do not guarantee a similar outcome. The contents of this podcast are intended for general informational purposes only, and you are urged to consult a lawyer concerning your own situation with any specific legal question you may have.